Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 1022. It's a sum of roots to binary leaf numbers. Okay, so the question is very important because the most people overcomplicate this problem and they build strings, they convert to integers and waste the memory. But there is a simple one-line binary trick that makes this problem easy. So today we are going to solve this problem, and after this video we'll understand the binary tree, binary math, right? Those things we'll understand and you will feel very natural to understand this type of problem. So let's try to understand here. So we have given a binary tree that contains 0 or 1 as a node's value, right? So each node contains either the 0 or the 1. Okay, that is why it is called a binary node. So each root to leaf, there is a path that forms the binary number. Okay, so each node contains some value, and those value either can be 0 or 1. So we must convert every path into decimal, right? Let's suppose if we have path from here to here, if we'll keep going like that, right? Means we'll come from here, then we'll come here, like this, right? We have the path. Okay, so what is just saying that we have to convert every path into decimal, okay? And we have to return the total sum. Okay, so let's try to understand. The very first, the question says that we have given root of the binary tree where each node contains 0 and 1. Each root to leaf path represents binary number starting with the most significant bit, and for each path, let's suppose like this, then this could represent this, which is 13. Okay, for all the leaves in the tree, consider the number represented by the path root to the leaf, return the sum of these numbers. It means we must convert every path into decimal. First thing. Second thing, that we have to return total path, we can say total paths, correct? Two things we have to do, and each root to leaf path, right, it forms a binary number, right? So we can understand that what we need to do. So each root to the leaf path represent a binary number, and so we must convert every path into decimal, and then we'll return the total sum we can say, total sum we can return. So this is what the question is saying that. Okay, so in this case, let's suppose what we have given here is we have given this what you call the binary tree, or the tree we can say, right? So the root to the path, what are the path? Let's suppose these are the leaf node we have, this one, this one, this one, this one. Okay, so these are the leaf node. So let's suppose if I'll talk, the very first we have is 1 0 0, then if will come to this way, this is also 1 0 1, then this is 1 1 0 1 1 0, then we have 1 1 1, like that we have, right? 1 1 1. So if we will represent this one, this one, this one, and this one, this will be some value will be there. So we know that the concept is 8241, 8421. If we will say this is 0, this is 0, this is 1, it will give you nothing but a 4, right? Then 101 means this will be 1 and this will be 1, means this will give you 5. Similarly 110 is this will give you 6, and this and no, this all these three as 1, so it is 7. Okay, now if you add all, so you will say that 4 plus 5, 6 and 7, this will give you 22, right? Means this is what the answer is also coming, 22. Okay, so we should understand what we need to do and how we are going to convert. Means every path represents the binary that forms the decimal values, right? And you have to do the total sum of those binary decimals, and you have to return it. I hope you're understanding. Let me tell you the another example so you can understand clearly. Let's suppose we have 1, then we have 1 here, then we have 1 here, right? So these are the 3 nodes very first we have. Then in the binary we have another is 0, and it has 2 children, 0 and 1. Okay, it is very easy. Now think that if we will represent, then the path is what we have, 1 0 0 we have, then we have 1 0 1 we have, and then we have 1 1 1. So this will represent 4, this will represent 5, this will represent 7. If you do the sum, right, it will become 16. Okay, and this will be our answer. So this, we have to convert this binary into decimals, and then you have to do the sum. Once the total sum will happen, you will return the total sum. This is what the question is saying. Let me tell you how I develop. Okay, so as you can see here, we have we will do the recursive way. We have the root, right? So we will start from the DFS root with its value is 0. So this is the current value, we can say, and we will pass the current node. So current node is root node and its value is 0, which means we'll start from the very first node, right? Which current value is, we will take as a 0. Then we'll find the current value. How? Let's suppose there will be the current value into 2, and we can get the node.val. You will initialize the current value. Then for the leaf node, right, what you need to do, node.left, if it is any of this one is null, will return true. Otherwise we'll continue to understand what is the nodes.left current value and node.right current value. Means we have to keep adding the current value here, and so we'll for the root node, right, there will be some value will be here, so this node value will be there, right? So we'll pass the node value in the very first. Let's suppose what is the root value will be here, that we are adding here, right? And we are updating current value. Similarly, we have to pass its next children, either the current or this current. Basically we want to add all those value what this makes the sum, right? So this is what we have to do, guys. And in case you are having any doubt, you can bring me in the comment box. What is the common mistake people here does, right? The mistake most people makes here is they build a string, they convert the string to integer as at a leaf, right? And they waste the time and space complexity that is unnecessary. Instead, use the binary math while traversing. You just need to find the current value. You have to keep adding onto the current, right? So the magic trick we have here is binary rule. Every time you read a new bit, right, that is nothing but current into 2 plus node.value. So this is called a binary rule. So every time when we read a new bit, right, just we need to update the current. Why? Because binary works like, so whenever we read a new bit, we have to update the current, right? Why? Because the binary works like, if we have 1 0 1, right, it means what? We will say that, let's suppose 1 into 2, then we'll do plus 0, and then we'll multiply with 2, and then we'll do plus 1. Okay, so instead of storing the full path, we will build the decimal value in step by step, and that is the idea here. Okay, so let's remember again, like we were saying that if we have 1 1 1 like this, then we have 0, and then we have 1, and then we have 0. If this is the thing we have, means we are saying that 16 will be our answer, right? So let's suppose that very first the start comes at here, right? So what will happen, we'll say okay, the current is 0. So at root, right, at root 1, what we'll say, at root 1 the current is, how will you find the current? You will find current equal to 0 into 2 plus 1 is nothing but is 1. Then we'll go to the left. Let's suppose we'll reach to here. Here what we'll find, okay, now current is what, 1 into 2 plus 0, and this will give you what is 2. Now we'll go to the left here, because we are going with the DFS, right? So each DFS approach will move to its children first, right? Then when we reach there, means basically okay, now we have 2 into 2 plus 0. So this is the current becomes 4. Okay, now we have reached the here the what you call the leaf node, right? Reach to here, it means we will return this 4. Okay, now we have to backtrack again, means we have to go to the right side here, right, where you will say okay, when we reach to the right one, what we need to do, we'll say okay, that current we have to find 2 into 2 plus 1, and this is 5, and this is also leaf node, so return 5 now. So finally you will return 5 here, means you have completed this node also. So here you return 4, here you return 5, right? Now your control will come here, means we are doing backtrack to the root node, right? So what will happen, when we're reading here, means we will go to this right. Now we'll say okay, 1 into 2 is 1 into 2 plus 1, right? 1 into 2, because it was 1, then we got the 2, then we'll say okay, into 2 plus 1, we'll say okay. So this node will give you 3. Okay, now what is the current here? Currently we got is 3. So we'll say okay, when we reach here at this point, we'll say okay, 3 into 2 plus 1 is nothing but what is 7. When we come with the point here, we'll say okay, we reach here, right? And no, sorry, when we come to the root node here, we'll reach to here, we'll get the 3, then we'll reach here and we'll get the 7. Now we have to add all. Let's suppose we saw that there was here we got 4, here we got 5, and here we'll reach 7. Now do the sum, 4, 5 and 7. What is the answer? We have to just do plus, it will give you 16, right? So this way we have to backtrack and we have to find, right? So every time whenever whenever you read a new bit, you have to just multiply current into 2 with the node value. Okay, and why? Because the binary works like this itself, right? So we have to multiply with the current value into 2 with the node value. Okay, so we are not storing any path here, right? So it will build the decimal in each step, and will keep adding all the value, and finally you will have the current, and you will return the DFS calculated value, and finally you will return here as a recursive value. So in this approach, it's very clean, no string, we have no conversion, we have one single traversal, we have pure DFS we are doing here. So it will, due to the DFS, it will take O of n as a time complexity and the space complexity. So space is basically O of h, means the height will be different. So time complexity is O of n, and space complexity will be the height, how much height we have here, the height of the tree, that depends on here. Okay, so okay guys, that's all I have in this video. I'll see you in the next one, and if you like this video, please hit subscribe to this channel and also share with your friends. Thank you.